Hello everyone. In this session, I'll be discussing some questions from logarithms. So let's start with the first problem over here. Express 2 plus log 2 base 6 as a single logarithm. So we have 2 plus log 2 base 6. Now you don't have a log over here. So what we can do, I can write 2 as 2 times 1 and 1 can be replaced by log of 6 base 6. We know that log of a base a is equal to 1. Condition a should be greater than 0 and a should not be equal to 1. So why did we take log 6 base 6? As we have the second term contain the base 6. So we can write this as 2 log 6 base 6 and this can be further written as log of 6 square base 6. That gives you log of 36 base 6. Now we can replace 2 by log of 36 base 6. So let's write it here, log of 36 base 6 plus log of 2 base 6. Now if we use the product law, log of a base b plus log of c base b, this is equal to log of ac base b. So if I use the same here, you get log of 36 times 2 base 6. So that results in log of 72 base 6. So you will say this is your answer. As there was to write it in single logarithm, so this will be the final answer. Now let's move on to the second question. Given log y base a equals k, express log of ay square base a in terms of k. So what is to be found out? Let's write down log of ay whole square base a. I can write this as log of a square y square base a. Now this can be written as log of a square base a plus log of y square base a if I use the product law, and this can be further written as 2 log a base a plus 2 log y base a. As we know, log of a base a is 1 and log y base a it's given as k. So if we replace that, you get 2 plus 2 times k. So this can be written as 2 times 1 plus k. So this should be the final answer. So you obtain log of ay whole square base a as 2 times 1 plus k. Now let's move on to the third problem. So over here you have log of 3 base 12 equals p. Now they're asking you to express log 4 base 144 in terms of p. So we can see over here the base 12 and 144. 144 can be expressed as 12 to the power 2. The common factor between 3 and 4 is 1. So we need to simplify this expression a bit. So given log of 3 base 12 equals p, what I can write it as? I can write log of 12 base 3. If I take the change in base rule, you can write 1 by p equals log 12 base 3, and 12 can be broken down into 4 times 3. So you write log of 4 times 3 base 3 equals 1 over p. Now you can write this as log of 4 base 3 plus log of 3 base 3 using the product rule is equal to 1 over p. Now log of 4 base 3 can be written as this term is equal to 1. So if I take it to the other side, it becomes 1 minus p over p. So we can write log of 3 base 4 as p over 1 minus p. So we have simplified form of log 3 base 4 in terms of p. Now we will use this to solve log 4 base 144. So let's simplify this. So log of 4 base 144. This can be written as 1 over log of 144 base 4. So this can be further written as 1 over 2 times log of 12 base 4. Now if I split 12 as 4 times 3, you obtain 1 over 2 log of 4 times 3 base 4. So this can be written as 1 over 2 times log of 4 base 4 plus log of 3 base 4, which can be simplified to 1 over 2 times 1 plus log 3 base 4 can be replaced by this value. So you write p by 1 minus p. This we can simplify to 1 minus p over 2 times 1 minus p plus p. So you obtain 1 minus p over 2. So this is your simplified answer. Right? So whenever you have these type of questions, you need to simplify both the parts and use the simplified version of this in order to find the second value. Let's move on to the next problem. So over here you have log of 2 base 6 equals a and log of 3 base 5 equals b. So you need to find log of 2 base 5. You can see over here, you can simplify this a bit. So let's do it. Log of 2 base 6 equals a. We can write this as log of 6 base a equals 1 over a using change in base rule. So it's base 2, not 6. So we can say log of 6 base 2 can be written as log of 2 times 3 base 2 and it's equal to 1 over a. So if we use the product rule, we can write 1 plus log 3 base 2 equals 1 over a, or you get log of 3 base 2 as 1 minus a over a. So let's keep this value. Now let's come to the point we are supposed to find log 2 base 5. So if I introduce a new base using the change in base rule, if I write it as log 2 base 3 over log 5 base 3, we already have log 3 base 5 and log 3 base 2. So if this can be written as 1 over log 3 base 2 and the denominator can be written as log of 3 base 5 divided by 1. So log 3 base 5 is b and log 3 base 2 is 1 minus a over a. This can be simplified to ab over 1 minus a. So you can say this is your answer. Right? Let's move on to a different type of question now. So over here you have log of x base 2 equals 25 log 2 base x. So you're supposed to solve for x. We can write log of x base 2 equals 25 times 1 over log x base 2, change in base rule. So now we can consider put log of x base 2 as t. So what do you obtain? T will be equal to 25 over t. So you can write this as t square minus 25 equals 0. And this can be split to t plus 5 times t minus 5 equals 0. So you get t equals 5 or minus 5. Now our t value was log x base 2. So I can write log x base 2 equals 5 or log x base 2 equals minus 5. So now if you convert this logarithmic equation into exponential, you get x equals 2 raised to the power 5 or x equals 2 raised to the power minus 5. So x raised to the power, x equals 2 raised to the power, we get x equals 32, or you can say x will be equal to 1 over 32. So we get two values of x. Now you can see x is in the base as well as the input of the logarithm. So the base should not be equal to 1 and it should be greater than 0, and whereas this should be greater than 0. So you can see either of the values of x, both are greater than 0. So both can be considered as the solution. So you will say both are the answer. So I hope you liked the problem solving part in the logarithms. Please do subscribe to my channel to stay tuned for more videos on this.